In the diagram, O is the center of circle ABCD, and angle BOD is equal to 146 degrees. Calculate the value of angle BAD. And so here we have this angle right here, angle BAD. So let me highlight it. So we have angle BAD. All right. So what angle are they referring to? They're actually referring to this particular angle. So we have to figure out what is the size of this particular angle, right? Angle BAD, they really want us to figure what is the one in the middle. So angle BAD, that's the angle that we have to figure out the size of. What is this angle, right? Now, one thing we know is we know that the angle at the center is 146 degrees, but how are we going to figure out what is the angle at the circumference? And we can use this theorem. It says that the angle at the center of the circle is twice the angle at the circumference, which means that if we know that the angle at the circumference is x, then the angle at the center is 2 times x. And so here we have the angle at the center, which is 146 degrees. And we know that this is twice the angle at the circumference. And so in order for us to figure out what is the angle at the circumference, we have to divide. So we say 156 degrees divided by 2, and that gives us, we have 146 degrees divided by 2, and that gives us 73 degrees. And so that means that this is 73 degrees. And that makes sense because if we say 73 multiplied by 2, that gives us 146. And so the angle at the circumference is 73 degrees, and that's the answer to this question. Next, our goal is to determine what is the value of angle BCD, angle BCD. So let's highlight that, angle B, C, and D. All right, angle BCD. All right. And so this is angle BCD right now. We actually want to figure out what is C, right? So what is the size of this angle? Now, one thing we do know, right? We do know from the previous question that this angle, let me use a different color, that this angle right here, that this angle is 73 degrees, right? We saw this angle right there is 73 degrees. And if you notice that this is opposite to this one, all right? That's important. And what else is important is that we're dealing with a cyclic quadrilateral, okay? So what do we mean by a cyclic quadrilateral? Notice that this quadrilateral, because it's a quadrilateral because it has 4 sides, right? 1, 2, 3, 4. And it's a cyclic quadrilateral because all of the vertices of this quadrilateral lies on the circumference of the circle. And so that's what makes it a cyclic quadrilateral. So, but we notice that these are opposite angles inside the cyclic quadrilateral. Now, what do we know about opposite angles inside a cyclic quadrilateral? Well, there's a theorem for that. And the theorem says that, okay, so this is just defining what a cyclic quadrilateral is. A cyclic quadrilateral is a 4-sided shape that can be enclosed by a circle. Each vertex of the quadrilateral lies on the circumference of the circle and is connected by 4 chords. And so that's what we mean by cyclic quadrilateral. And the theorem says that opposite angles in a cyclic quadrilateral have a total of 180 degrees, which means that these two angles add up to 180 degrees. So if we know that this one is 73, in order for us to figure out what this one is, we're just going to say 180 minus 73. Just like how if we know that this one is x, I want to figure out what this is, we just do 100 minus x. 180 minus x. And so in order for us to answer this question, we say 180 minus 73. And 180 minus 73 gives us 107. And so that means that the size of angle BCD is actually equal to 107 because 107 plus 73 is 180 degrees. Next, we need to figure out what is the size of angle OBD. So let's highlight that angle, angle OBD, right? Angle OBD, okay? So what we really want to figure out is what is the size, let me use a pen, what is the size of this angle, right? Angle OBD, right there. Because we're really focusing on the one in the middle, angle B, right? Okay, so what do we know? Well, we know that we're actually dealing with a triangle. So if you look, notice carefully, this is a triangle. What else do we know? Well, we know that if we have a line segment that runs from the center of the circle to the circumference, if we have a line segment that runs from the center of the circle to the circumference, then that line segment is actually the radius of the circle. And again, if you have a line segment that runs from the center of the circle to the circumference, then that line segment is the radius. So both of these lines are radiuses of the circle. So that means that both of these are equal, okay? So we actually have a triangle in which we have two sides are equal to each other. And so we're looking at an isosceles triangle. If two sides of this triangle are equal, then we have that the two angles are equal, which means that whatever this angle is, this angle must be it, right? These two angles are equal because we have two sides are equal and we're dealing with an isosceles triangle. But what do we know about the angles inside of a triangle? Well, the angles inside a triangle add up to 180 degrees. And so what we're gonna do is we're gonna take 180 and subtract it with 46, right? And that gives us 34. But we have to take 34 and we have to split it into two equal parts, right? This must get a share and this must get a share. But those two shares must be equal, all right? So this amount and this amount, those two angles must be equal to each other. So we take 34 and we divide it in two. That gives us 17. That means that this is 17 and that is 17 and all of them add up to 180 degrees. And so that means that the size of angle OBD is 17 degrees. And that's the answer to this question.